This video is part of the chapter Competition in the course Evolution of Plant Interactions at the Ostrava University. In the previous video, we saw how competition for one resources can lead to the competitive exclusion of the species that requires more of that resource for its growth. In the next two videos, we will see what happens when two species are competing for two resources. The outcome of the competition depends on the potential interaction between the resources, which was described in the video named Multiple Resource. The equations for these models are a bit complicated. Luckily, they can be visually represented using isocline plots. Here we have a scenario with two essential resources. When one species is using two resources, we can calculate its equilibrium state, which is defined as zero growth rate of the population. We already saw that this is true anywhere on the isocline. For any of these resource abundance combinations, the population growth is zero. Namely, the number of newly produced individuals will be equivalent to the number of lost individuals. However, being at the isocline point does not necessarily mean that there is an equilibrium between resource consumption and resource supply. For a stable equilibrium, this condition must be fulfilled as well. This is achieved as a balance between resource supply. Let's start with the resource consumption vector. As a vector, this has a numerical value and an orientation in space. This vector is specific for this population and this isocline. It tells us how much of each resource does the population consume to achieve this specific growth rate. If we decompose the vector in two components, one aligned to the R1 axis and the other one to the R2 axis, the lengths of these vectors tell us how much of each resource does the species consume. The angle of the vector corresponds to the relative proportion of the two resources, here resource 2 over resource 1. In this example, the species consumes approximately the same amounts of both resources. For two essential resources, we can deduce the consumption vector graphically because it corresponds to a line that goes from the plot origin through the corner of the isocline. It does not matter where exactly is the vector placed, the amount and relative proportion of the two resources consumed will always be the same. Note that the resource consumption vector is different for different growth rates which correspond to different isoclines. For this isocline, the population requires more of the resource 2 than the resource 1 to grow. This is shown by the length of the component vectors and also by the wider angle of the resource consumption vector, which corresponds to the ratio R2 over R1. Now that we know how to define the resource consumption vector, we also need to define the resource supply vector, which tells us how fast are the resources renewed in the habitat. The resource supply vector is dependent on the environment, specifically the amount of the resources initially present in the population's habitat. This is defined by a resource supply point. Without getting into specific details, Tillman's resource ratio model assumes that the supply vector is always pointing to the supply point. So if some resources are consumed, the supply vector will be pointing directly towards the original supply point. If the population consumes more of the resource 2, then the direction of the supply vector will change. It doesn't matter in which direction the resource levels are depleted, the supply vector will always be pointing to the supply point. Remember that the resource supply point is dependent on the environment. In a different habitat, the supply point can be different and the supply vectors will also change direction. At equilibrium, the resource consumption vector, which is a property of the species, and the resource supply vector, which is a property of the habitat, will be exactly the same in length and orientation, but they will be pointing in opposite directions. So once we estimate the resource consumption vector, which is always parallel to the line going through the corner of the isocline and the plot origin, and if we know the supply point, we can easily find the supply vector. This is a vector that lies on a line parallel to the resource consumption vector and intersects the supply point of the habitat. The point on the isocline where these two vectors meet corresponds to the population equilibrium state. The growth rate of the population is 0, and the resource consumption and supply vectors are equal and opposite in force. This is nice and simple, but we have only considered what happens when one species is limited by its growth by two resources. In the next video, we will see what happens if there are two species and two limiting resources.